Hello, my name is Louis Pritchett, and today I'm going to demonstrate the use of a shift register or a register that could either act as a parallel register or a shift register. This is an 8-bit device, and I will demonstrate its use and illustrate its construction. This is the pin diagram that I used for the construction of this 8-bit shift register. I needed to use two ICs, 27495 ICs. Let me orient it this way, because that's pretty much how it's oriented on the trainer. The A, B, C, and D are my inputs that were connected to switches. QA, QB, QC, and QD are my outputs that are connected to logic indicators. 1 is my serial input, 6 is my mode control. Pin 6, if it had a high signal, which was a 5-volt signal, caused the register to be in the parallel or load mode. If it experienced a low signal, it acted as a right shift register. Both ICs were grounded on pin 7 and connected to a 5-volt source on pin 14. 8 and 9 are my clocks. Since I only needed one clock, I tied everything together on one shift. Everything together so that I would have one clock. In order to have these chips function together, because each chip contained 4 bits, I connected the QD output of one to the serial input of the other. Now let's look at the actual circuit. Again, these are my inputs coming from my switches, and these two chips are the actual shift register. The upper chip is my least significant chip. The lower chip is my most significant chip. In order to get them to work together, I tied the Q sub D output of the least significant bit chip to the serial input of the most significant bit. These are my outputs coming from my Q outputs on the shift register chips, and they go to the logic indicators. Again, each chip was grounded on pins 7 and connected to 5-volt sources on pins 14. In order to change the mode, I use this SBDT2 switch. By pressing the button and having the indicator across from the red wire, which is connected to a 5-volt source, a high signal was felt, which caused the register to act as a parallel register. By pressing it so that the light is across from the ground wire, a low volt signal or a low signal was felt, which allowed it to behave as a right shift register. Now let me demonstrate how this will work. First of all, I'm going to demonstrate how it works as a parallel register. I'm going to change all my bits or turn them all off. And this is indicated by everything being green. And well, better yet, let me turn them all on, because the indicators are green or off. So anyway, by turning on all of my inputs I will load them into the logic or the shift register all at once. And to do that, I need to press the SBD2 switch so that a high signal is felt. And then by pressing the clock pulse, everything is loaded all at once. Again, let me demonstrate again. I'm going to turn everything off. And again, by pulsing the clock, everything is loaded all at once. Now, in order to indicate how it works as a serial register, I need to change the mode to a low mode or 0. And that's by pressing this SBDT2 switch so that it gets a low signal, which is connected again to ground. I am going to load, I'm going to turn on the serial input bit, and by pulsing the clock, it will be loaded into the register. And there it is. Now it will take 8 pulses in order for this register to be completely full to be completely turned on, which is indicative of the input bit going from position B7 to position B0. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now again, I will demonstrate in reverse by turning this off, and then I'm going to pulse it and load it, turn it off, and then 7 more pulses, and all of them will be turned off. Indicating each pulse will indicate the serial input moving from B7 from one position to the next position on the right. So I'm going to, B7 will be 1, 2, 3, 4, 5, 6, 7, 8. And there you have it. I've demonstrated to you how I constructed an 8-bit register that could act as a serial or parallel input register. I demonstrated to you how to load it and how to get it to shift. Thank you very much.